Okay, this is a Hewlett-Packard 5381A. It's an 80 megahertz frequency counter. Has an attenuator times 1, 10 and 100, and you can change your gate time, which will change the display capability for frequency, the number of decimal points you can carry. It'll go from 0.1 second to 1 second to 10 seconds. You'd use the 10 seconds for a slower frequency rate in the hertz range. If we did that right now, every 10 seconds you get an update to the counter. We are right now feeding a frequency in from this little calibrator that I have. I'm feeding in a 20 hertz signal at the moment. And as you can see, after the 10 seconds, we have a 20.0 hertz signal showing here. The low frequency on this counter is actually kind of surprising. I wouldn't expect that it could actually handle something that low accurately. Its bigger brother here, the 5382, which is a 225 megahertz counter, is not accurately displaying this frequency. It does fine at frequencies 50 and above, but at this frequency we're picking up something else, and it's counting false counts. If we change to 50 hertz, we should be able to see both change. We are on the 10 seconds right now. We're going to change that in a moment. We'll wait, get the one update, and then we'll change. There's 50 on the right, 50.1 on the left. Alright, we're going to go to 1 second intervals. And we see 50, 51 on either side, which is normal. You're good to within a count usually. There's 100, 200, 500, 1,000, 2,000, 5,000, 10,000, 20,000, and 50,000 hertz. This HP is doing a marvelous job at resolving those frequencies up to 50,000 hertz. And I realize that's not the megahertz range, but it certainly would cover anybody's audio and do it very accurately. We'll continue on, and we'll hook up to this Interstate Electronics 20 megahertz sweep generator, and we'll do some further testing there. Okay, we're now taking our output from this IEC 20 megahertz generator, and we are currently putting in 100,000 hertz, and this is not crystal controlled, so we can only dial in close. We've got 100,000.125, 128. It varies a little bit on the last digit, but you can see both of them are varying together, which is a good thing. Alright, let's take her up to the end of this range. Should be able to hit about 200,000 here. Okay, 200.232, 235, it varies a little bit, 240. But you can see they're both going together. Okay, let's take her up a range. I'll take her down to the bottom here and come up. Okay, let's start at about 400,000. Okay, there's 400.5 both units. Let's take her up to a meg. Okay, there's 1,817,820 hertz. Let's go on up again. Take her up to 2 meg. Okay, there's 2.0019, 2.002 megahertz, 2,002,000. Okay, let's just go ahead and take her all the way up to the end of this thing and just prove that we got some room here. Yeah, we're going to take this range on both of these up. We are now into the megahertz range, so I had to turn my gate time up. We are reading 25.447 roughly megahertz. 25,447,448. It's varying a little bit. My oscillator is not that stable, but you can see they're both varying together. So the point is, it's a very good unit. It's measuring fine. I tell you what, we'll do one more check. We'll take her up to as close as I can get to 80, just to show you that we have that limit. We can handle that top end. All right, we are now tracking about 54.7 megahertz on both units, as is being fed from this B&K E200D RF generator. And you see that both units are reading identically, and so we're getting up to just about 55 megahertz here without a problem. My problem is I can't generate a signal that will reach 80, so I can't go all the way to the end, but we've hit substantially the range here. So this is a working unit. It's attractive. Really hasn't too many blemishes. The face is yellowed a little bit. There used to be a sticker on the front here. Somebody could still put a sticker on it with their name if they want it, but comes with a stand, rubber feet. It's compact, fits well on a bench, gives you 80 megahertz capability, and it's working well. So good luck, guys.